this one, and the A, B, C, identical balls is telling, and the ball B is given velocity V0. They are lying on a smooth horizontal surface. So what is the other balls? They are at rest. We are projecting so and these are the strings. They are just out, you can say. So where is the string now? Okay, the string. Now he's asking find the then velocity of A in the direction of velocity of B just before collision. What actually happens here? So after some time, so what do we see? We see a situation there at rest. Let me show sequence of diagram. This you can try all these things at home. These are not something very big. This one. After some time, where do we see this? So initially they are here. After some time, when this is moving here, shall we go for sequence like this? And this will have say velocity VB1, this will have velocity VA1, sorry VA, component of velocities I'm showing it, C, A, this is B, and definitely a tension will be acting, string will be taut, called tension T1. Then finally, what will be the sequence? I think this is not needed. Next sequence, what will happen? At one instant, so what do we see is like a, this will be the ball B. Ball B will have velocity VBY. These will have velocity Bx, By, By, Bx. I'll give the color. It'll be easy to identify. What makes them to move like that? This is very important. Now look at the ball A and C. The tension which is there in the string, so what it does, will end up the diagram like this. Look at the node. The moment I project it, so then they are connected by a string. So what this string will do? So this string, what it does is like string will become taut and the tension starts acting. So how do the ANC? ANC will move in a plane. ANC will move in a plane. So they just don't move like this, they'll start moving somewhere here. Then the B, what happened, has to move along this vertical line. Any reason for that? Because what is the net force on the B at all the time? You look at the component of tension. Because this length is L. Symmetrically it is placed here, in the diagram also given. So therefore net force on the B at any instant of time, if you go and check it, no? Theta, theta. The net force on the B at any instant of time, when you go and check it, it will be along x-axis will be 0. So then what this tension does, it does negative work on the ball B and it does positive work on the ball A and C. So what makes the ball A and C also to acquire horizontal velocity? Component of tension, and the tension will make it to accelerate along y-axis also. So finally we'll get a situation like this. Now can we say this VBY equal to Vy? Yes, in fact. Just they are about to collide. Okay, this is the condition. So some tension will act here. Let's not bother. What is the net force on the system along y-axis? Now also it will be 0. T1 cos theta, T1 cos theta. So the net force on the system along y-axis 0. So therefore initial momentum equal to final momentum. What is the initial momentum given? All the mass of them be mv naught. What is the final momentum? mvy plus mvy. So what is vy equal to v naught by 3. Okay, this is the initial velocity. Like this we can calculate. So what is this? Is 9 by 3. Just when A and C are about to collide. Now again is asking with what velocity A and C will collide. How to calculate this Vx? We don't know this Vx. Net work done by tension will be 0 here. So therefore I'll go for conservation of mechanical energy. So what is the conservation of mechanical energy? M v naught square by 2 is equal to 3 times of m vy square by 2 plus 2 times of m vx square by 2. Then I know vy, I know v naught. Substituting, I'll get vx. Then what is the velocity of A with respect to C along x-axis, or velocity of A with respect to C should be equal to Vx minus Vcx, and Vx equal to Vcx equal to Vx. So it will be Vx minus Vx, 2Vx. So do we know Vx? I'm going to calculate from here. So look at the roll of the string. I think you can just take this, any thread, some beads will be there. Mass m and m, no, kinetic energy of this plus this. Okay, y2m, the kinetic energy of this and this. y3m, kinetic energy of all three along y-axis. So all these are some ideas of conservation of linear momentum. Only I have to check it net force 0 or non-zero. Net force 0, momentum is not conserved. Net force, net external force is 0, momentum will be conserved.